Hi, welcome to my channel Industry 4.0. Today, in this video, we will discuss basics of Ethereum programming. Please like and share the video and subscribe to my channel. Different programming languages. Ethereum smart contracts run on compiled bytecode. That means there may be several high-level languages in which code can be written. Ethereum has a number of languages available in particular. 1. Solidity. It is the most popular language now, 2020. 2. Viper. This is a language by Vitalik Buterin with an emphasis on security. 3. LLL. Low-level Lisp-like language. 4. Mutant Golan-like, deprecated in 2015. 5. Serpend, Python-like, but seems to be no longer maintained. 6. Bamboo. What exactly is a smart contract technically? A smart contract is a state machine like the execution of bytecode. It runs on the Ethereum blockchain and gets executed by all nodes in the network. Normally, it is written in high-level languages which compile the code down to assembly and bytecode. EVM assembly and opcodes. The Ethereum virtual machine understands several opcodes in EVM assembly, which are represented by bytecodes. The bytecodes are instructions for the EVM to read, write, jump, store, etc. It may read and write from or to a stack or to storage. One good list of available opcodes is listed in this following Stack Exchange thread. https://ethereum.stackexchange.com/questions/119/what-opcodes-available-for-the-Ethereum-EVM40T and can also be found in the Ethereum Yellow Paper https://ethereum.github.io/yellowpaper/paper.pdf. Gas and gas requirements. Every operation on the Ethereum blockchain is performed by following the bytecode or opcodes. Each opcode costs a certain amount of gas. The different gas requirements may be found on page 26 in the Ethereum Yellow Paper https://ethereum.github.io/yellowpaper/paper.pdf. The maximum amount of gas available has an upper ceiling of currently around 6 million additionally. The execution is limited by the maximum amount of gas a user can provide and a miner would accept, in other words. This definitely leads to multiple problems software developers face. 1. We might have only a few users during the development of the smart contract. Then in production, when things start to scale, the contract suddenly runs into out-of-gas exceptions. 2. Loops are the biggest trap. We should never use loops if we don't know how much gas it consumes at all times. Gas costs economics on the blockchain. The gas is calculated by how complex the transaction is to be executed. And the reason why we pay in gas rather than Ether is that in this way the actual dollar costs may stay constant even though Ether might get much more valuable. For example, a transaction that interacts with a contract needs 4 million gas to be executed. We offer 2 GWh per gas, which is 2*10*9 Ether *4*10 equals 2*4*10*3 equals 0.008 Ether, or at the time of writing, this would cost us around $5. During network congestion, the gas price can rise. The miners always take decisions that which transactions to include in the next block, and there is not an unlimited amount in one block. Basically, the reward the miner gets when transactions compete by gas and gas price. If we decide, for some reason, to offer 50 GWh for the same transaction to speed it up, we'd pay 50*10*9 Ether *4*10 equals 4*50*10*3 equals 0.2 Ether or $140. A big difference, as you can see. Data storage in a Merkle-Patricia tree. Ethereum has its own, efficient, system to store information. This system has to be cryptographically secure. All key value bindings in Ethereum are stored in a Merkle-Patricia tree that is held in a state tree, a storage tree, a transaction tree, and a receipts tree. Privacy on the Ethereum blockchain. The biggest issue on the Ethereum blockchain is the privacy issue. There are ZKS and ARKS now, but one of the biggest misconceptions is that private variables in Solidity are private. All data, in general, is public. In a programmatic way, defining a variable private just means that it can't be accessed from other smart contracts. The programmer may access all private variables information within 10 minutes, give or take. An additional layer has to be created that encrypts information to ensure privacy on the blockchain. This is still a matter of active research.